instantaneous rate of change. So again, the difference quotient, f of x plus h minus f of x divided by h. Yes, I have this. Yes, I have this. I don't have this, like before. That's the only one I'm missing. Not a big deal. I'm looking at this function to see what it tells me. It shouts this at me. This is what the function is shouting at me. It says f of whatever equals the square root of 4 minus whatever. Now, I would like, since we're here for this function like we had before, what is the condition I have to write for the existence of this function? So forget about this for a moment. So for the previous function, you said, oh, very clear, x minus 1 cannot be 0. So the domain is everything but 1. But what about this function? What do we know about the square root? What numbers we can take the square root from?
It has to be positive.
Yes, or?
It can't be negative.
Or? Positive or?
A fraction.
Or? So we have numbers that are positive, numbers that are negative, but we also have a number that is not positive and is not negative.
Oh my God.
Oh, 0.
0. So this quantity, 4 minus x, has to be greater than or equal to 0. Okay? So we move 4 to the other side. When I move a term from one side to the other, I only change its sign. What do I need to do now to both sides?
Divide by 0. I mean negative.
Multiply or divide by negative
Negative
1.
1.
Very good. So this will become positive. This will become positive. What happens next?
You flip the sign.
Flip the sign. Awesome. So then the domain of this function is from negative infinity till 4 with a bracket. We're going to discuss this again today. I mean, domain for other functions. Good. So now I'm coming back to the target. Stop me if you have questions, right? Everyone, yes?
Yeah, why did you say it has to be greater than or equal to 0?
How much is the square root of 4?
2?
Excellent. How much is the square root of 0?
1. I thought it was 1.
How much is the square root of 1?
1.
Good. How much is the square root of 0? They cannot be the same.
0.
Excellent. And now my last question is, how much is the square root of negative 4?
They were square. There's no answer.
Yes, not a real number. So this will be 2i, imaginary. So that's the reason why the quantity under the square root has to be greater than or equal to 0. As long as it's greater than or equal to 0, I get an answer. If it's a negative number, I don't have an answer. Does that answer your question?
Yes.
So since we are here, I'm going to write this. For any even index, positive or 0. For every odd index, anything. This is friendly. I like to call it friendly. You don't have to. This is not. Here I worry. Every time I see an even index, I worry. When I see an odd index, I can sleep tight. I don't have to state any restrictions. Good. So finally coming back to the difference quotient. Can anyone give us the f of x plus h for this function? It's okay if you're wrong. Yes, Ben?
Would it be radical 4 minus x plus h?
You didn't say parentheses.
sorry, yeah, press.
Or you distribute.
Okay.
So you either say parentheses, because I have a minus in front, or you say 4 minus x minus h. Whichever you prefer, but you have to say one or the other. Is that clear, everyone? Yes?
Yeah.
Okay, perfect. How do we deal with this? When we had a quadratic function, we used this pattern. When we had a rational function, we had to find the least common denominator, find these quantities to adjust the 3 multiplied by x minus 1 and then by x plus h minus 1. But now this is a totally different function. What do I do with this? Because I cannot add these. I cannot take square roots. Let me refresh your memory. This is called rationalizing, this time the numerator. You can say nobody ever told us that we can rationalize the numerator. We're told to rationalize the denominator. Yes, but in this particular case, we will rationalize the numerator. Anyone remembers what does that mean?
You square them?
We can never square.
Oh.
So this is like saying I have $10 in my pocket. Let me square that. What will I get? $100 squared.
I think, isn't it you multiply by 1 over it?
I multiply by the conjugate. So I'm going to write it one more time because I cannot do that there. So the difference quotient. So when to finalize the idea here, if you say that the square root of x equals 2, and you tell me you must square both sides to solve, then I would say yes. But if I have the square root of 2 over 3, you cannot say, yeah, just square that and you get 3 over 9. That's not possible. If I have an equation, yes. But just out of pocket, just square something. I can't. Okay, good. So I'm going to copy this and then multiply here. So the square root of 4 minus x minus h minus the square root of 4 minus x divided by h. And remember the complex conjugate, or the conjugate. This is why I reviewed this formula. Maybe I should just keep this here on the table because I'm pulling them out of the recycling bin. So if we have a plus b, then we need to multiply top and bottom, which is 1. Top and bottom by a minus b. If I have a minus b, then I will multiply top and bottom by a plus b to get this. So I'm going to keep this here. Good. So I have, in other words, a minus b. So I need a plus b over a plus b. This entire quantity has to be 1. Multiplication by 1 doesn't change anything. So can anyone tell us what to multiply and divide by? And it has to be the same quantity, of course. It's okay if you're wrong. Anyone would like to try? I have the a minus b. I just need the a plus b. What will the a plus b be?
Would it just be the square root of 4 minus x or minus h, and then you would do plus
Exactly. That's all it is. I didn't mean to write that, sorry. That's why I have my whiteout handy, just in case. Good. Awesome. So now a minus b times a plus b is this piece squared minus this piece squared. We have it right here. That's why we reviewed it. I take the first quantity and I square it minus the second quantity, I square it and put it here. Good. So a minus b, a plus b. So what do I get now?
Wait, is the top numerator supposed to be minus or plus?
So
You said a minus b.
we have a minus b. We need this quantity to make this. So we do have the minus. We need the plus. Is that what you're asking?
Yeah, that's fine.
Good. So now we have to square this. Can anyone square this and tell me what to write?
You just take it out of the radical, right?
Sure, just tell me what to write and I'll write it.
4 minus x minus h.
Very good. Now I have to copy minus. I have to put parentheses. Can anyone square this?
Four minus x.
4 minus x. Very good. Over this whole thing with h, of course. Minus x minus h minus this plus, of course. 4 minus x. Good. So remember note number 1. What has to happen? Otherwise, I'm not on the right track. All terms without h must simplify in the numerator. Okay, so let's see. I will write it one more time. 4 minus x minus h minus 4, but plus x. If those do not cancel out, then I'm in trouble. So, the negative x with the positive x, goodbye. The positive 4 with the negative 4, goodbye. So, note number 1 happened. Now I have negative h in the numerator, there is nothing else. H, the square root of 4 minus x minus h plus the square root of 4 minus x. So now note number 2. Note number 2 says h from the denominator must simplify. Does it?
Yes.
Yes. Factors, only factors. So here's the final form. 1 at the top. So this whole thing in the denominator. The square root of 4 minus x minus h plus the square root of 4 minus x. This was a good refresher on rationalizing as an example. Good. Now I wanted to talk about, I think we had enough of these. Any questions for me? Any questions? So now we have one more topic before we continue. It's called piecewise defined functions. What's the big deal? Here's an example. I'm making stuff up, okay? I do not know the tax code. I submit my taxes with the TurboTax, whatever they ask, I put it in. So I don't know the tax code, but I'm giving you an example. So here's a function. It gives us the percentage. So for someone making between, I don't know, 0 and $10,000, I'm making stuff up. Let's say they pay 2% in taxes. Between 10,000 not closed and 50,000 making stuff up, 12%. And so on and so forth. Let me give one more example. Let's say between 50,000 not closed, it's already here, and 100,000, let's say 30%. And I can go on forever. This is a piecewise defined function. The function that I just created, it's not the actual tax code. I was just giving you an example. And as you see, it's a different function for different values of x. Between these two, I consider 2%. Between these two, I consider 12%. So these are different pieces. They will not graph like this. That's not a function. I will graph the first piece at 2%, the next piece at 12%, and the next piece at 30%. They will not cross. Okay? So something like this we're going to discuss right now. There are many other examples of piecewise defined functions. So I would like us to choose a problem. I'm going to share my screen. I will let you choose a problem. Where are you guys? As you know, you're far away from me, so I have to go back. I'm sharing. My computer is getting out of juice, so let me put it in.